Hello everyone. This video is on the Knewton Alta assignment for section 4.6 part 2 called Equations of Parallel and Perpendicular Lines. So in this video I'm going to be doing a preview version of this assignment, so please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment yourself. But all the objectives are the same, the structure should be similar. So I'm hoping that watching me do these here helps you in some way when you work on the assignment on your own. Now on your assignment page you should be seeing the title, the mastery bar telling you how far along you've gotten, the objectives. Looks like there are 2 objectives for this assignment. Under the current objective, you should have a question related to that objective. And at the bottom of every question, you should be seeing a feedback button where you can send feedback to Knewton if you wish. You will not have an instructor cheat button. That's for instructors only. But you will have a more instruction button. If you're ever struggling with a topic or a question, click on this and you'll be taken to a page with some reading or videos to study, and then you'll be given questions related to that instruction, and completing those questions is another way to progress through the assignment. Alright, so this first objective I'm looking at is find an equation of a line perpendicular to a given line. So in this first question they're asking us to find the equation of a line perpendicular to this line. So the line they're giving us is x minus 5y equals 4. That contains the point negative 1, 2. So our line, the line we're writing the equation for, has the point negative 1, 2 on it, right? This line doesn't. Right? If x were negative 1 and y were 2, this would not be true, right? Write the equation in slope-intercept form, right? Y equals mx plus b. Alright, so I'll write out the situation here. So our line, right, the line we're writing the equation for, is perpendicular to the line x minus 5y equals 4, and contains the point negative 1, 2. Now, before I get into our line, let's look at this line that they gave us. All right, and I'll draw like a quick picture of it. Now if you want, and I would suggest this, put this into slope-intercept form, because we're going to need to know the slope of this line to know the slope of our line, right, because our line is perpendicular to it. And I'll refresh your memory as to what that means in a second. So if I were to solve for y here, right, I would subtract x and then divide everything by negative 5, giving me y equals positive 1/5 x minus 4/5. Right. So this line has a slope, and I'll call this m1 because there are going to be 2 lines here. I'll call this the slope of the first line. This line has a slope of positive 1/5. Right, if you were to graph it, and I'll go to the Desmos calculator in a second, but first I'll make a rough hand drawing. This has the point 4, 0 on it. Right, if x were 4 and y were 0. And it has a slope of positive 1/5, so if I went up 1 unit and then to the right 5 units, It should also have the point 9, 1 on it, right? If x were 9 and y were 1, this would be all true. So here's their line. All right, and I'll draw this in one color. So like an orange here. So here's their line. All right, the line they gave us. Slope of 1/5. Now I hope you recall that perpendicular lines have negative reciprocal slopes or opposite reciprocal slopes. I like using opposite reciprocal, but they may use negative reciprocal. Or you could also say the product of the slopes of perpendicular lines is always going to be -1. If you multiply the slopes of perpendicular lines, you should get -1. So that means the slope of our line, which I'll call M2. If the slope of this line is 1/5, the slope of our line, right, a line perpendicular to it, should be -5. Right? Just do exactly as it says here, opposite reciprocal. The opposite of 1/5 would be -1/5, and then flip that over, take the reciprocal. The slope would be -5. And it contains the point -1, 2. Right? So -1, 2 is on this line. And it has a slope of -5, meaning from this point go down 5 units to be at y equals -3, and then right 1. So it should have the point 0, -3 on it as well. I'll draw this in like a greenish color. And these two lines, one has a slope of 1/5, the other has a slope of -5. These two lines should intersect each other at a 90-degree angle. Right? That's what it means to be perpendicular. Right? And slope 2 equals -5. And what we want is the equation of this second line, the equation of this line that has a slope of -5. Now, I already we did this in the last video, section 4.6, part 1. You should know how to write equations of lines. All right, so our line has the following equation: y equals mx plus b, where the slope is -5, and I can see from my picture that the y-intercept is -3. So y equals -5 times x minus 3. All right. And there we go. That's what they want. Now, if you didn't see the y-intercept in the picture, remember you can use the point, right? -1, 2. We'd have y equals -5x plus b, plug in -1 for x and 2 for y, and then solve for b, and you'd get b equals -3. Right? Either way. Or there was a third option. You can use that, remember, point slope form, right? Y minus 2 equals -5 times x plus 1, the quantity x plus 1, and then solve for y there. But like I said, you can refresh your memory as to how to write equations for lines in section 4.6, part 1. I'm not going to go over all that again. You should know how to write equations of lines once you know a slope and a point. And there we go. Y equals -5x minus 3. There's the line, the green line that I drew, that's perpendicular to the line they gave us, and it also passes through the point -1, 2. And if you'd like to see a better picture of this, better than my hand drawing, go to that free online graphing calculator at desmos.com. All right, the equation they gave us was x minus 5y equals 4. All right, there's that line. And the equation I ended up writing was y equals -5x minus 3. And hopefully you can see that these do cross, and it looks like they cross at a 90-degree angle, right? It looks pretty good. Also, right? The point negative 1, 2 should be on that second line that just came up. If I plot the point negative 1, 2, see, there it is. It's on that second line that is perpendicular to the first line. So that equation looks good. So back in the assignment, y equals negative 5x minus 3 is the equation they're looking for. All right, then after you submit an answer, it should tell you if you're right or wrong, and then give you some sort of answer explanation. Please read through the answer explanations just to make sure you understand why something's correct or incorrect, and then hopefully you can learn from your mistakes for future questions. All right. Next. All right, so it's still the perpendicular objective. So just remember the slopes of perpendicular lines are opposite reciprocals, or in this case, if one line is horizontal, a perpendicular line will be vertical. All right, two lines are perpendicular if the products of their slopes is negative 1, or if one of them is horizontal and one of them is vertical, which is going to be the case here. All right, so here, like, find the equation of a line perpendicular to y equals negative 6. All right, this is a horizontal line, and I'll draw this. That contains the point 1, 3. So it's just going to be x equals 1. We'll see that. X equals 1. So I don't know why they're saying write it in slope-intercept form. X equals 1 is not slope-intercept form. I think that I'll leave some feedback, or you could leave some feedback on a problem like this if you wish. Yeah, so on my paper, so again, the line we're given is y equals negative 6. Remember what those look like when it was just y equals some number. And you go to negative 6 on the y-axis. So 0, negative 6 is on there. 1, negative 6 is on there. 2, negative 6, right? This is a horizontal line. And remember, the slope of a horizontal line is 0. Now I know it doesn't look horizontal because, again, this is a terrible hand drawing, but this is horizontal. All right, the slope is 0. And if the slope of this line is 0, right, a line perpendicular to that is going to have an undefined slope. Right, our line has the point 1, 3 on it, and it's perpendicular to this, so that's going to be vertical. All right, it's got to be vertical. 1, 1, 3, 1, negative 6, 1, 1, 0. A horizontal line, perpendicular, has got to be vertical. Remember, the equation of a vertical line is x equals the same number all the time, and in this case, if the point 1, 3 is on there, it's x equals 1, and that's all we're doing. All right, that's the equation. And they clearly meet at a 90-degree angle. Now again, for a better picture, right? For a better picture, I'll go to the Desmos site, and y equals negative 6. So there's that blue line that just popped up on the bottom here. And then x equals 1 is the equation. Clearly, right? Clearly these meet at a 90-degree angle, and the point 1, 3 is obviously on this. Right, because x equals 1 all the time. Right, so that one's not nearly as tricky as some other ones might be. But it's not in slope-intercept form. I would just leave that feedback for Newton. Say, hey, the answer here isn't in slope-intercept form. Right? There's no y in the equation. No, I put x equals 3. I meant x equals 1. Oops, haha, don't rush. But they give me another shot, so hooray. Yeah, I put x equals 3 for some reason. X equals 1. I wrote x equals 1. I said x equals 1, but I typed x equals 3. Just don't rush. Check your answers. The nice thing is sometimes they give you another shot, so that's good. All right. Sorry about that. All right, so now we get to the other objective, which is going to be very similar. You're given one line, and then you're asked to write an equation for another line that goes through some point, but it's either parallel or perpendicular to it, but this time it's parallel. All right. So like with the perpendicular case, I'll write out what's happening here. And I'll draw a little picture. So what's happening in this question is, our line, the line we want to write an equation for, is parallel. That's the key word here, is parallel to the line they gave us. Now the line they give us is negative 5x plus y equals 2, which is very easy, again, to put in slope-intercept form. That would just be y equals 5x plus 2. Just add 5x to both sides to solve for y here. And contains the point 5, negative 2. Alright, so the slope of this first line, m1, the slope of the line they gave us is 5, positive 5. Alright, and I can draw this pretty easily. I'll try to make my axes look a little better. But this would have the y-intercept 0, 2, clearly. And then slope is 5, so I go up 5, and then right 1, so the point 1, 7 would be on this, and you can see that if x were 1, y would be 7. So here's the line they gave us. Right, here's the line they gave us with a slope of 5. And then you just have to remember what it means to be parallel. Now, perpendicular lines had opposite reciprocal slopes, right? The product of their slopes was negative 1, or one was horizontal and one was vertical. Parallel lines had the same slope, have equal slopes. Alright, so that means for our line, I'll call this slope 2. The slope of their line was 5, the slope of our line is also going to be 5. And it passes to the point 5, negative 2. So here's 5, negative 2. And the slope is again 5, right? The parallel lines run in the same direction without touching. So I go up 5 from negative 2 to 3, and then right 1 to 6. 6 for x, 3 for y. There's 6, 3. And again, this is a hand drawing. These might not look parallel, but they should be. Or maybe I should do this and say, they're touching, sure. I just wanted to make it look more parallel. There we go. But they should be running in the same direction, and they'll never cross. They'll never hit each other. And and you should know how to write an equation of a line when you know the slope and a point. Right? We have y equals mx plus b. We know the slope is 5, so y equals 5x plus b. And then I can solve for b using this point, right? Replace x with 5, y with negative 2. We have negative 2 equals 5 times 5 plus b. And then, b would be negative 27, because this is 25 here, and then I subtract 25. So the equation of our line is y equals 5x minus 27. That's this line here that I drew, the second line. It would hit the y-axis at negative 27, but still have the same slope. Remember, parallel lines have the same slope but different y-intercepts, right? Because if they have the same slope and same y-intercept, they'd be the same line and not parallel at all. They'd be right on top of each other. But this is it. All right, and this has the point 5, negative 2 on it. Same slope as that line, parallel. You can see in my drawing. You could also go to the calculator if you want, look at a better picture. But I'm not going to do that this time. So y equals 5x minus 27. Great. All right. And again, you see how they're using the point slope form first and then solving for y. You saw that again in section 4.6 part 1. I'm not going to go into all that again. All right. Now, again, the ones with the horizontal and vertical lines should be pretty quick. find the equation of a line this time parallel to y equals 2. Now y equals 2 is horizontal again, right? When y equals the same number all the time, that's a horizontal line. So this should be another horizontal line. And it passes through the point 4, 1. So I can make it a quick drawing of that. Y equals 2 looks like this. And you got 0, 2, 1, 2, 2, 2, right? The y coordinate is 2 all the time. Right, there's y equals 2. Now remember, this has a slope of 0. So that means our line also has a slope of 0 and is also horizontal. And if it passes through the point 4, 1, right, here's 4, 1, well, that means the y coordinate must also be always 1, 3, 1, 2, 1, 0, 1. Right, here's our line. Right, that's parallel to that one. And that would be the line y equals 1. Right, the y coordinate is 1 all the time. And that's all I'm putting. Y equals 1. So again, just pay attention to whether or not the word perpendicular or parallel shows up. That's going to make a big difference. All right, this one's just as simple, only this is a vertical line. X equals 1. This has an undefined slope. It's vertical. So, we have a line parallel to that would also be vertical. Also have an undefined slope. And a vertical line that passes through the point -2, -1 would just be x equals -2, right? X equals -2 all the time. That would be another vertical line. X equals -2. And these two should be parallel. You can draw them on your own and check it out. Okay. Alright, and then one more. I'll write this one out again, but I won't draw any pictures this time. Alright, you can do that on Desmos or on paper on your own if you wish. So I'm just going to find the slope of this first line. And once I have the slope, I'll know that our line has the same slope because it should be parallel to it, and then also pass through the point 4, 3, and we'll write the equation in slope-intercept form. Right. So the line they gave us, right, where we are parallel to -3x minus 5y equals 4. I'm going to solve this for y, get this in slope-intercept form. So I would add 3x and then divide everything by -5. So this would be -3/5 x and then minus 4/5. So the slope of this line is -3/5. Remember, it's the coefficient of x once you've got it in slope-intercept form. So that means this is the slope of our line as well. Our line's slope also, because we're parallel. And our line contains the point 4, 3. So y equals, -3/5. Oops. Y equals, the slope -3/5 times x plus b. And I plug in 4 for x, 3 for y. You'd have 3 equals -3/5 times 4 plus b, and then we can solve for b. This would be 3 equals -12/5 plus b. Now 3 is actually 15/5, right? When you get, because I'm going to be adding fractions and need a common denominator. And then 15/5 plus 12/5 would be 27/5. So our equation is y equals -3/5 times x plus 27/5. That's what they want. -3/5 x plus 27/5. -3/5 times x plus 27/5. Great. Alright, and then we should go back to the perpendicular junk. Just remember that perpendicular lines have opposite reciprocal slopes. All right, the product of their slopes should be -1. All right, so same deal, but the word perpendicular is there. All right, our line is perpendicular to this line, 4x minus y equals 2, and if I solve this for y equals 4x minus 2, the slope of this first line equals 4, meaning the slope of our line, and this is our slope, the slope of our line must be -1/4. The opposite reciprocal. And then the point that's on our line is 4, -2. So you got y equals, -1/4 times x, and then plus b. I want, when x is 4, I want y to be -2. Now when x is 4, this will just be -1. So I would need to add 3, subtract 1 to get -2. So b would be -1. Y equals -1/4 x minus 1. And again, you could figure that out on your own pretty quickly. So here's the line perpendicular to the line they gave us, going through the point 4, -2. Y equals -1/4 x minus 1. Great. And I should have just one more of these with the word perpendicular in it. Alright, so again, I'll write this out. So our line is perpendicular to this line, 3x minus 2y equals -3. If I solve this for y, and you can easily see the slope, I would subtract 3x and then divide everything by -2, so it'd be positive 3/2 times x, and then plus 3/2. So the slope of this line is positive 3/2, meaning the slope of our line, right, our slope, m2, is -2/3, right, the opposite reciprocal. And a point that's on our line is -5, 5. Right? So we want y equals -2/3 times x plus b. I put in -5 for x, positive 5 for y. So 5 equals, now -2/3 times -5 would be positive 10/3 plus b, and then 5 is 15/3. And I subtract 10/3 from both sides, you get b equals positive 5/3. Right, so the equation of our line is y equals -2/3 x plus 5/3. There's the line that's perpendicular to the line they gave us and would contain the point -5, 5. Great. And I'll enter this here, -2/3 times x plus 5/3. Great. All right, and that should be, and again, please don't forget to read the answer explanations. And that should be it for this preview version of this assignment. And like I said at the top of the video, the questions I saw here may not be the same as the ones you're going to see when you do the assignment yourself, but the objectives are all the same. The structure should be similar. So I'm hoping that watching me do these here helps you in some way when you work on the assignment yourself. And thank you very much for watching.